Hi everybody, welcome to scientific method number 3. So today we're going to be doing another experiment, and the reason we're doing this experiment today is to focus on how to make a hypothesis. What is a good hypothesis? What is a bad hypothesis? So let's have a look together. Today's experiment is based on this. How does the intensity of exercise affect the heart rate? How does the intensity, that means how strenuous, how energetic the exercise is, affect the heart rate? Well, let's think about the background. The first step is to ask a question. The second step is to collect some information. So I've collected the information for you already. Now, to do work, the body requires energy. Speaking, I need energy. Eating, I need energy. Walking around, I need energy. For the body to do anything, the body needs to have energy. Secondly, exercise that is more intense requires more energy. If you run, you use more energy than if you walk. Energy comes from respiration, cellular respiration. And respiration means that glucose is burnt in the presence of oxygen to release energy. It's the oxygen plus glucose creates carbon dioxide, water, and energy. Now, oxygen is supplied all around the body through the bloodstream. And it's the heart that is pushing the blood throughout the whole body. So this is the background information. This is what we need to know in order to make our hypothesis. So let's make a hypothesis. Now, a hypothesis needs to be a prediction. You are guessing what is going to happen. If I do this, then this will happen. It's based on evidence that you've collected, and that's what I've just shown you on the previous slide. It's got to be specific. It can't be vague. Something will change. Something will change is not a guess about what will happen. So we need to be precise, specific. We need to say what we think is going to happen. So based on the experiment that we're talking about, which is the best hypothesis? The heart rate will be higher with less intense activity. The heart rate will be higher with more intense activity. The heart rate will be the same for all activities. Or exercise will affect the heart rate. Pause the recording now and choose which of these 4 you think is going to be the best hypothesis. Well, the last one, exercise will affect the heart rate. This is too broad. We're not saying what we think is going to happen. We're not saying if the heart rate will go up or it will go down. There's no prediction here. It's just a very general idea that exercise will affect it, but we're not saying how it will affect it. So this one cannot be correct. These 3 are all predictions. Heart rate will be higher, the same. We're predicting what will happen. The heart rate will increase, or we're saying the heart rate will stay the same. But based on the information that I gave you, which one is better? Remember, more intense activity needs more energy. More energy means we need to have more respiration. More respiration means there needs to be more oxygen going into that reaction. And the oxygen is coming from the blood. So if we need more oxygen, the blood has to come more quickly. And so the heart has to beat more quickly to supply the oxygen to the body. So I would say the second one is going to be the best prediction. The heart rate will be higher with more intense activity. This matches the information that we have already. But now we're going to do an experiment to test this. So in this experiment that I've recorded for you, the volunteers are going to perform 3 different activities. These activities will have different intensity. One will be quite easy, one will be middle, one will be very difficult. Each activity will last for 60 seconds. The heart rate will be checked before and after each activity. Before, we call the resting heart rate, okay? So we need to know what the heart rate is before we begin to exercise. And the difference between the before and after will show the change due to the activity. And then between each activity, there's going to be a 4-minute break where the heart rate can reduce and get back to normal. So The rest of this video is going to show you the experiment that we recorded last weekend.
Okay, so we've already looked at the experimental method, we thought about the hypothesis, and now it's time to do the experiment. So we have several volunteers around us, and the first thing we need to do is check what is the heart rate now. So, Adelaide, you're going to check Lala, Simon, you'll check me, and Pecan, you'll check Tono. When I say go, 1 minute on there, you count how many beats for 1 minute, and then Adelaide will tell you to start, Adelaide will tell you to stop. Okay?
One will start.
So you're going to check. You all found the pulse? Is he alive? You start already? Okay. So now they're checking the heart rate. So it's very important to check the heart rate at the beginning because we want to know the effect of exercise on the heart rate. Now, if we don't check what the heart rate is before the exercise, if we only know what the heart rate is after the exercise, then we have no idea to compare. Was it higher or lower than at the beginning? So we have to check the heart rate at the beginning. So that's what we're doing now. Pause. Okay, so now we've finished checking the resting heart rate. We want to know what they are. So what was PP's?
97.
97. Very high, but then again it is quite big. What was mine?
74.
You see, I'm more healthy. My resting heart rate is quite low. And then? 107. So his resting heart rate is normally what you'd have for someone doing exercise. That means he's almost dead. Never mind. Now we're going to start doing some exercise. Okay? So we're going to do 3 exercises. The first exercise is very easy. We're going to walk up and down here. Okay? Pee-pee. Come here, Pee-pee. You can move out of the way. So we're going to start doing the exercise, just walking up and down, because this is not very heavy. So, 3, 2, 1, start. Let's walk up and down. Now, we want to start with a light exercise because we're testing how the intensity of the exercise will affect the heart rate. We already thought about before the experiment that the more exercise you do, the more movement you have, the more energy your muscles will need. And the more energy the muscles need, the more respiration is going to occur. So, this one is very light exercise. We need more energy than when we stand still because our legs are moving. But we don't need a lot of energy. So we should see a small change in the heart rate, but we should not be seeing a very big change in the heart rate. Let's see. Pause there. Okay, time is up, so now we need to check the heart, now we need to check the pulse again. We have to check it very quickly after the exercise finishes. If not, then it's not an accurate test because people's heart rate might have changed again. Okay? We start on 56 seconds. So we can do 4 seconds after. Don't listen to the bell. Listen to me. I'll tell you when to stop. Okay?
67.
67. We'll stop a little bit early, so add on a few more. So it's probably 74. What was mine?
77.
Okay, we started a few seconds early, so make it 79. What was this?
110.
110. So we add on a few more. 113. Okay. Start again. Okay, so we've checked the heart rate again. After the first piece of exercise, what was his heart rate?
67.
67. And mine?
77.
Okay.
150.
113. Okay, stop there. Okay, so we've just finished the first piece of exercise. Now we need to check what the pulses are. So what was his pulse?
70.
70. And mine?
79.
Okay, and
150.
113. Okay, so that's the end. Now we're going to take exactly 2 minutes rest to get the heart rate back down again, and then we'll check our pulse before we start to do the second piece of exercise. Join us again when we check the heart rate at the beginning of the second exercise. It'll wait 2 minutes. Okay, so we've just checked the heart rates again. We're about to do the second exercise. My heart rate was, Simon?
75.
Mine was 75, my new resting heart rate. Tonos was
97.
97. Like his heart rate go up and down like a yo-yo, but you know. And his
91.
91, his heart rate's coming down slowly. Now, we're going to do 1 minute of medium level exercise. So, Sidhu, tell us when to begin.
Start.
Stop the video. Pause the video. Higher! Higher! How long left? Keep it up.
20 seconds.
20 seconds. Higher! Keep it higher! Oh, this is the elephant jumping. Never seen before.
8, 7, 6, 5, 4, 3, 2, 1.
Okay, now 1 minute. Restart.
Start.
So now we're checking the heart rate again to see how the second exercise affected the heart rate. Okay, so now we've checked the heart rate at the end of the second activity. As you can see, one person already died. But what's my heart rate?
100.
Now my heart rate is 100. What's Lala's?
106.
106. Less than before he started doing everything. What was his? 109. So we see that all the heart rates increase since the resting heart rate at the beginning of the second exercise. Now we're going to take 2 minutes rest so that our heart rates can become normal again. Maybe 5 minutes rest. So his heart rate can become normal again. And then we'll do the third activity, which is the most difficult, the most energetic, running up and down. Hey, wait till you start.
Start.
So it's very important, before we do the last activity, to check the resting pulse again. As you've seen, we don't always have the same resting pulse. The amount of water in our bloodstream, the amount of energy our bodies are using, lots of different things. Even pressure or excitement or anaerobic, lots of different emotions. These can also affect the resting heart rate. So it's really important when we're doing this every time that we check the resting heart rate before we do the new activity, to make sure that we know what we are comparing to. So we do for 1 minute every time, and then we do the activity straight away afterwards, and then we check the pulse again at the end. This time is going to be the most energetic activity. We're going to be running on the spot and hitting the knees. How long's that?
10 seconds.
Okay. Okay. What's my heart rate?
91.
91. So it's not quite a resting heart rate. It's not come back down to where it was before. What's his?
88.
88. You sure you know how to count? And you?
85.
85. Maybe my heart rate is a bit more quick because I'm actually speaking to you, so I'm still using some energy while we're doing it. And that might be one source of bias in the experiment. Now, we're going to start our exercise. So, exercises, come here. Sidhu will tell us when to start.
Start.
Quick, quick, quick. Come on, baby. 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 Up, up. Come on, baby. Come on, my shot.
5, 4, 3,
Guys, ready?
2, 1. Finish.
Start. Start.
Start.
So now we check the heart rate again. Okay, so we've checked our heart rate for the final time. The final heart rate for me is
102.
102. And for Lala?
106.
106. And for Pipi?
9.
109. So that's the end. I would like you to rewind the video, look at all of those results, and put them into a table by yourself. Later today, I will show you what a correct table would look like. But for now, just find the results and put them into your own style of table. What's that, Psycho there?
So now I'd like you to make a table to show the results. You might need to watch the video again and listen as people are calling out the different heart rates. Think about how you're going to organize the information. I'm not showing you. That will come in the next video. But for now, make a table to show the results, and later there will be a Google quiz based on this experiment and based on the idea of making hypotheses. Good luck, everybody.